Hi everyone, my name is Oren, and there's two things about me. I always have a bad hair day, and my English isn't that good. So I'm not sure you can help with the first one, but if you don't understand anything of what I'm saying, either technical or just my English, so let me know. You can stop me, and I'd love a question, so you can stop me at any point of the talk. If I'll say I'll answer that in a few slides. So that's the worst thing that could happen. I don't have any candy to throw at you. Oh, actually, I do. Ooh. So if someone answers, so I'm not sure if it should be like a bad thing or is it when it's a good thing if someone answers a correct question, so he gets a trophy or something. I guess I should probably have what he had with the blue stuff. That was cool. Okay, so you should probably start. So just to find out how many of you are write code for a living, you yourself write code. Wow, so many developers. And how many of you have write, not just once, unit tests, right? Wow. And how many of you write end-to-end testing? So that's less. So we are going to be a little bit technical in the middle and the end of the session. So there will be a few lines of code, just a few lines. So please stop me if I'm going too fast or too slow. Just let me know. So we should let's go start. So regarding testing, we all know. I see that you all know the question, the answer already. So between a theory and practice, well, in theory there's no difference between them, but in practice there is. So we always start, every application starts beautifully. So and after a few weeks, it becomes like, so we all know and it happens everywhere, usually in startups. I worked in companies like IBM, the WebSphere, group communications, and it all started nice, but eventually it turned out things like this, and Cadence, and I've worked at a lot of web development at startups like Weeks, and I have a startup of my own right now. And it all starts pretty nice, and it turns out like this. And we all start with, oh, that would be simple. And then it turns to something hellish, and then we'll said, okay, let's have testing so we can, we do want to refactor. So testing comes in handy, and that's what you probably know unit testing. So I want to straight up just what people mean when they talk about all those testing, the jargon. So we have a unit. Every unit has, you can test the unit, but then you can have several units, so you probably want to test a bunch of those together, so that's integration test. And if you have everything together, so that's called end-to-end testing. But there's more than that, but when you write end-to-end testing, what do you test? Do you test just the functionality? So if you check that if I have a calculator and write 1 + 1, will it result 2? That's the functional testing. It does result what I wanted, but does it look exactly as I wanted it? Is it in the same place? Maybe it's hovering over the numbers, not in the correct location. Of course, I can check performance to see what if I run it once and it works? What if I run it 1,000 times and then it doesn't work? So maybe I have memory leaks. And the 100,000th time, it won't work. So, and of course, you can't always run all the tests if you have a complex project. So sometimes you want to run just a specific test to make sure that there's no fire inside. That's called smoke testing. And adding everything together, the performance testing, the functional, everything together, that's called acceptance testing. And usually, until now, it required manual testing. That could be because you'll see in a second why. So here is everything we wanted to just mention. And of course, we know the difference between white box and a black box. You said you're unit testing. So unit testing is you look at the gory details, but on the other hand, everybody's using it. You had more people here using unit testing than end-to-end. And the question is, of course, why? Why? Of course, we have different metrics for unit testing, or inside even a unit, we can either check, look at it as a black box or white box. So black box means, I don't know, I don't care about what's the inside. I can check for, let's say, memory consumption or response time. And usually it's something like resembles user stories. You don't have very simple tests. It's not just 1 + 1, and then let's start a new test when 5 multiply 5 by 20. There are longer tests. Let's go log in and do something else. So white box, there's usually code involved. But the question is, that's not the reason everybody is doing unit testing. Unit testing looks harder, so why is everybody doing unit tests? Well, unit test, of course, in my opinion, it makes you write better code. That's one of the best reasons to write tests. You get, out of it, you get regression tests for your unit, which is great, it's a hard work, and of course, when something goes wrong, you know exactly what went wrong. So it still doesn't make sense that if you go to Google and let's say Gmail and write an email and send it to ourselves and check that we received the email, we'll probably go over 40% code coverage in a 5-second test. So why do people prefer unit test over end-to-end? So why? The granularity, what I mean by this stupid graph is that to get 100% code coverage, which is the minimum of what people see as testing, as a good testing, you need to have a lot of unit tests, but you can have that in end-to-end in very, very few steps. So what's so wrong? Again, it's called the reverse ISCOM, which means that usually people base themselves currently on unit testing, a few integrations, very, very, very few acceptance tests, and manual testing. Usually that employs as well exploratory testing. You give someone, just browse the application for an hour and see if you find random bugs somehow. So we want to find out what exactly is the difference between it. So for example, if we take the login, in unit testing, it seems very, very easy, okay? I have a new account, I'm starting, it's all the same. You have a setup, you have a stimuli, and then you have a validation. So you have a setup when you start a new account, then you do a login with a username as a password, and then what you usually do is you assert that you've moved from one state of the application to another, and the new state is correct, or it's at least part of it. So in end-to-end testing, let's throw away the intro and start looking what's so bad about end-to-end testing. Well, you probably want to try open a browser. That will be set up, and then we'll set up the username, we'll set the password, and we'll click the login, and then we'll validate that we're logged in. So I'm going to talk about mention Selenium code in this talk, but everyone's have the same level of abstraction. Selenium is they all navigate, let you steer the browser. So they all give you exactly the same thing, which is usually navigate to a URL, some URL, find some element, an HTML element, and let's add some text to it. And then that's the stimuli, the setup, the stimuli, and then we'll have, for example, this is Google. This is real Google code. They have this example at the Selenium code. They improved it just a bit lately, but you go to Google, you search for cheese, and then you get a result, and you make sure you have, let's make sure we have 10 results. And the first thing I did was last year, and it failed. I ran it, and it failed. So what? I just started it. This is the hello world, and it fails. So what's going on here? So we can see in short that it's it looks the same, but it's not. Usually, it's not the same language. If you're coming from front-end developers and Selenium until now, most developers wrote in Java. So you had to learn a new language. So you wrote your application in JavaScript and HTML, and now when you want to test it, you need to learn a new language. For most of them, that sucked. And in unit testing, we're very accustomed to having everything synchronized. We can do all the, of course, for the advanced feature, we do the mocking for some of the things that are asynchronous, but usually you call a method and then you assert that the state changed. And here it doesn't. That's why it failed, because when the browser actually wrote cheese, it takes time for the browser to send an HTTP request to the Google servers and get the answers back and display the result. So it's asynchronously done. And we'll see about the setup, because usually when you write a unit test, you just run it on the machine that you're running. For example, is anyone of you aware of who knows about continuous integration server like Jenkins or TeamCity? Yeah, so they get a list, they get your code, they get a list of tests, and they run it on the same server. But with here, you need a browser. So if you want to have a browser open, how do you parallel it to have like 100 threads? That's okay, running 100 threads on the same continuous integration system. But can you run on the same machine, let it open 100 browsers? No, it won't scale, not more than 3, 5. So you'll probably need extra nodes running out there. So we'll talk about this. We'll go a little bit to the internals of how Selenium works and how they solved it, and of course all the points you can drop there. Well, the answer for most of the question starts with the basic thing, which is the page object design pattern. Who here is familiar with the page object design pattern? Oh, that's great. That's the answer I wanted to hear. And I'll introduce you to the page object design pattern. It's so simple, but nobody uses it. So I've found two quotes that should probably represent it. It's one of it that they're saying is, there's a service that you want to expose. This is the page object. Don't use the implementation. So don't use, this is Simon wrote Selenium, and it says, he said it really correctly when he says, if you're using Selenium code in your test, when you're writing tests, you're doing it wrong. It means you have to use abstractions. The difference is that if you have, we'll take an example and I'll show you. If you have the login screen, which is basically an email, a password, and a submit button, so usually your code will look something like this. You find the email and you set text. You find the password and you set text, and then you click the login, and that's your test. That's the basic test. But they say no. Well, Simon says no, and I'll tell you why. When I was working at a company called Wix, and I was one of the architecture when they moved from Flash to HTML a few years back, and then of course they wanted to be continuous deployment, and they had a few students writing tests, and they wrote exactly like this, and it was very, very slow, and they used the same locators how to find them. It's over and over in different files. So you do want to have one of the basic rules in software engineering that everything is Turing complete. So, but there's classes. We can organize our software in such a way that everything that is related to one component we'll put in the same file. So what you actually want to do is something like this. You want to separate. This is the page object, which I think that the word page object is kind of it's wrong, because it doesn't mean entire project, entire page, sorry. It means that something that in your business domain, in your business logic, your model, when you want to model it right now, what you're doing is reverse engineering. You have your engineers that had a model like a user, and then they created a web application related to that model, which is comprised of HTML and CSS. And now what you have to do is like a reverse engineering and have an account, for example, an account page object which has the same business model as in the backend. For example, doing the login. A gallery should have a go to next image, previous image, and show full screen. So here's one of it. So this is how you write this is called the page object, and this should be your test. Your test should probably be your what you want to be. You want it to be synchronized, so it's going to be very easy. It should be almost closer to English. That's why some of it there's a few projects that you even write in English, but I actually prefer writing code over English. So you have here, you're writing in something that is very similar to English, but it now has nothing to do with the implementation. You're just using the business logic, and the implementation is right here. Tomorrow you can move to another implementation, and it still works. So the nice thing, by the way, about it, does anyone who here knows about the V model? It means that you have the requirement, and then you split it up to the design, and then you implement, and then you're doing unit testing, and then you're doing the integration test, and then you're doing the end-to-end and the acceptance test. But it's weird because you can write if you're using the page object model, you can write the test even before you implement. Because if you do know that you have a user and a gallery and you know all the components that you're going to use, you can even write the tests. You can write, if you had this class as an account as an interface, you can write all those tests even before the implementation, or at least concurrent. So you can write it as when you have the requirement already. When you finish the requirement, you can not just do the design, but actually write the test as well. So that would speed things up. That means in a cycle. It doesn't mean you don't have to be agile. So if you want to expose a service, so let's start in exposing a service. So we have our login page, our account page, and we'll create our test. We'll have just create an instance and do the login. So, and here's the code right here. Class, we have the login, and this is the interface. Can anyone tell me what's wrong with this class? Why won't it compile? Indeed, my friend. Woohoo! Yes. It doesn't have a return type. Well, this lecture is in Java, but it doesn't matter if it's Ruby, JavaScript. It doesn't really matter which language, because everything is. Here we're here about trying to think, and it doesn't matter what language, if it gives you a compiler or not. So let's see both options. So we have an option of doing. Let's say it's going to be void. Okay. So our code will probably be like a new login page, and then we'll click the login. We'll call the login method. Well, it has one advantage, which it means the login page deals with just the login. It doesn't know where it's going to. I'm dealing with the login. I can do the implementation of the login will just be the login. I don't know anything about where I'm supposed to go. But it doesn't answer the next question. Was it successful? Is the new page ready? So if it's not ready or not, if we don't know, we need to add some weight there and not have a weight between it, then it won't be synchronously. So we don't know anything, and so that's the disadvantage. So we'll go to option number 2. Having the login return an instance of another page object, which is the gallery page. So it looks something like this. It just returns a new gallery. So our code is actually starting to look like this, having the login, doing the login, returning a gallery page, and then the gallery does the full image. Well, we are only missing the sleep, the wait till page load, so we'll deal with that in a second. So what I'm suggesting, let's put the sleep inside the login, and we end up with this code. creating the here's the setup. creating the setup, doing the login, the stimuli, and now we're doing the showing. It's synchronously. It looks very synchronously. You call a method, and of course we do the assertion that we'll get to that in a second. So we still have that, but we'll deal with that in a second. So what if we chose void? Because can anyone tell me an advantage of choosing void over a gallery? Why would we choose void? The gallery solution looks nice, so what's the big advantage about void? Sorry? The login fails. Yes, there's the login fails, and yes, and the fact that we don't know exactly where we're going. So this one means we don't know where we're going, but now whoever using us, he does know where we're going. So we can do something like this and add a static method for the gallery page, because the gallery page, he's supposed to know when we're ready. He knows. You always have to write some code because we said it's asynchronously. The question is, where do we put the code? Where do we put the code who's waiting, who says the code that's telling us the page is ready? So we'll put in the gallery if it's the gallery. So we'll probably want to do something like this. Having the gallery page has a static method, which is wait for page. And actually, the best, you can combine the two. If we combine the login that returns a gallery page and combine it with having the login page returns, he asks the gallery, come on, wait, let me know when you're ready. And the gallery page says when he's ready, and then I'm returning a gallery. I get the both of two worlds, actually, because because what I'm getting right now is the login. I'm making it synchronously since the login returns the gallery, and the gallery, he's the one who knows how to wait for a page. He's the only one who knows, because later on it won't be the gallery, it will be another component. So of course we're thinking about reusing, and we say, well, wait a second, every page in the internet is probably loading asynchronously if we have a single page application. So why not have it there's something similar here and here as well. So what we're trying to do is code reuse. So we can have using, I forgot an extend here, a gallery page which extends a basic page which has the method wait for page. So what's wrong with this? Why won't this compile? Sorry? Because it's abstract? No? Nothing, something else? Yes. It can't be static. It can't be. If you want to have overrides, you can't have static method. You have to, if you want to have virtuals, it has to be real objects, so you can't have it. But we have a quick solution, which is it. We're removing it. So everybody thinks about static is bad. You have to remember that. And they just say singletons are bad, so static methods are bad everywhere. So here as well. So you can use a wait for page, like an abstract, and that means that every implementation here, it's an interface, and then it means that every component that you write, it must comply and add its own wait for page, which is good. Actually, you can do even Java, you can even do better. Instead of returning a basic page in Java, you can return a gallery page, and it still works because a gallery page is a basic page as well, because we're extending it. Well, my personal recommendation would be probably to have it the wait for, not have it as a method. Have it just in the constructor. Having you write a new gallery, and the new gallery have it every everyone has a constructor, so have the constructor do the wait for you. So, and of course, in the basic page, you can add more. Let's wait for spinner to fade. If you have some common functionality, you should probably add all that inside. So, so let's go back to the Selenium grid. So, after we know right now how to write basic code, just how to split the parts. The question is, why do we need in Selenium? Why do we need grid? Because the API of Selenium, as I told you, that's very, very simple. The API is open a browser, find an element, click on it, or write text, or get text. That's it. Most of the drivers they're so simple, and on the other hand, we saw that nobody using them. Everybody using unit tests. And we said that if we want to have parallelization, so we want to have a lot of browsers. So how do we do that in Selenium? It's called Selenium Grid. So Selenium Grid is what we're doing. We're taking a lot of machines, those agents, and we're putting agents on them, and then we're taking another machine, and we're making it, of course, the master of it. And then he's organizing everything, so we just request from him, okay, give me an IE8 on the Windows 89 machine. And that's his role right now is getting you a browser. So you want to disconnect between our test and getting the browser. I want to disconnect those two services. So we want to have is this thing called Selenium Grid, who knows how to get me a browser, just a browser on a grid or a browser in the cloud. So how do you know, how does it work? We have to learn a little bit about how Selenium works. So, so Selenium supports most of the popular languages, most of them. So, and they wanted to support all the browsers, not just all the browsing, all the operating systems, and even mobile native applications. So how do they do that? So one standard to rule them all, they used HTTP requests. So what do you mean by HTTP request? Because what we have is so many languages which need to work, everything needs to work with all the operating system types. I want to run my test in Ruby and Python, still run it on IE or Firefox. So the solution was the wire protocol. It just means just sending HTTP requests. You're writing your test, it doesn't matter on which language, but you're using a Selenium SDK. And what it does, it doesn't matter in which language, when you say, I want to click something, it sends an HTTP request. The same HTTP request would come from either one of those this SDK. It's called the bindings. So it sends an HTTP request, and every browser in every operating system has something that knows how to translate those, listen to those HTTP requests, and do those requests on that specific browser. It will be different browser, a different driver for Chrome and Firefox. And for Firefox, it's an XPI, it's a Firefox extension. Here you'll have, if you're on Windows, you'll have to download something called chromedriver.exe. And it works. It means that you can work on every browser with every language. And this is how it's done. We instantiate you're using the SDK that we are downloading. We're writing new Chrome, and that will open an instance of the bindings. It will use the driver to open just one single line. It will open a browser on our machine, and it will start sending HTTP requests, which is the wire protocol. So first of all, the annoying part is all those drivers, you have to get them yourself. So you have to get the SDK, but usually you only need to get one. So because if you're using Java, you'll probably add one of the snippet line to your POM, and it will download the entire code and entire SDK. So every one of them on the left side, it's very simple, but now you have to download all those drivers. So there's a project, called Protractor, and they added 300 lines of code that will surely help you out, which means they will download for you all the Chrome drivers depending on your operating system. They just look, okay, we're using Windows, okay, so and I'll download Chrome driver and IE driver and the Firefox driver. That's it. The Firefox driver actually comes with the browser, and probably in Selenium 3, I guess it will come with the browsers, but it's not there yet. You have to bring it out on yourself, so you can use that to get all the Chrome drivers. So actually, what we want in a grid is actually that we're want to write the same code. Well, get me a Chrome, and then I want to click it, but now the bindings and the Chrome will probably be on two different machines, because I don't know exactly where it's going to spawn from. I'm going to ask it for a browser. Someone's going to get me a browser, but I don't really care where it is. I just need to know where this guy is staying, and I can send him a message. And this all happens underneath you. So setting up a Selenium grid isn't that hard. You open a you open a machine, you download everything is the same same jar. So you use different arguments to send it, to make it either a node or a hub or a node. So you have it on one machine, you say, okay, you're the node, and then you have it, you start two other nodes, you run them, but give them a different role. You give them a role of a node, just a node, and that guy, we gave him a role of a hub. So we got two agents hooking up. We give him the address of that machine, or where he's staying, because we gave him, we have his IP. We started the machine, and of course we gave him an IP, a port to listen on. Now we can give those guys, tell them what port they should listen on and where he's sitting, and that's simple. And from now on, when we're missing one more thing, which is connecting between him and him. That's what we're missing right now. So this is how you do it in Chrome. You start when your setup, instead of writing new Chrome right now, which starts it locally, what you have to do is you tell it where the hub is. We said you know its IP, and you know, of course, it's on which port, so we can start it. And we tell them, okay, I want a Windows machine, and I want to run Chrome on some version. And then I just send, oh, come on, get me a driver. And what it does, it sends him a request, telling him, oh, get me a driver. That's the capabilities. It means it's a general word for which browser. Because it doesn't mean it's a browser. You can send the capabilities like an Android app and give it the application name. And then it's going to look for all the nodes that subscribed and said, I'm available. And he orchestrates everything, and he knows, okay, I know there's someone, this guy is not busy, so I'll give you him. I'll give you his address, and he's going to mark that he's going to use it. And of course, there's a lot of people that, it sounds so simple, so the question is, why do we need, if it's so simple, there's a few Selenium browser in the cloud vendors, and there's open source by two companies, Groupon and Retail Me Not, which open source what they're doing over Selenium Grid. So at first I asked myself, why exactly, before studying it, I studied why is there extensions, why are there people writing, if it looks so simple. I can fetch up a few nodes, and then in Selenium Grid, they will do all the work. But the answer is that Selenium, it's not that sophisticated, and if one of the nodes, for example, hangs and doesn't answer, he doesn't know it, so you have to reboot you want to reboot one of your agents, one of your machines, you probably want to reboot them. So it seems that what people do usually is rebooting. If you have a machine that's running Windows and the IE, they reboot them after, you have to reboot it after every 10 tests. Every time you open the browser, you told them to open a browser and you do some clicks. After 10 times, they usually reboot it because they feel it will probably get stuck by something. So that was IE8. So IE9 is better, but they still, most people who in the QA system doesn't trust it, and they reboot it every 100 times. So instead of running your own code with Chef and Puppet to take it up and down, some people wrote some code which does that. So that's the Selenium. So you'll probably need that as well. You must have Selenium grid. So this is a trick question, especially with this projector. So the question is, of course, can you spot the difference? There's a few differences here, and it's very, very hard to spot. So the question is, the first things we should ask ourselves: why isn't everything? Why do we still have manual testers? If we can do everything automatically, why do we always need manual testers? And the question is that, and the answer is that even this simple thing as finding out if there's two images are identical, it's a hard thing. And of course, if someone could tell us that we have differences, it doesn't show really, really well here, but there's a big differences. There's things that aren't here, that are here as well, and of course the misspelling here. So a computer can do a comparison between two images and find the differences in a second. So why aren't we using this? And given and trying to do assertion using the image instead of just using text, asking the DOM and finding out, you get so many advantages. For examples, what if your z-index, if you had someone should be, this is what we expect, there's an image above the text. And what if the z-index wasn't correct because the CSS was wrong? And the images, if you ask the DOM, it says, do you have an image? Can I find the image? Of course, he's going to tell you, sure. And, but the z-index is wrong. What if the size, if you find an element, it says it's there, but the browser says it's there, but how do you know it's the correct size? I've seen a real application that had the failures because they said the width of the app isn't 1024, but 124. And they passed all tests. So, and then there's the flying pony from Google, which is, they added a feature someone added a feature that should be used only by administrators. And it accidentally went to, and all the users saw it, the flying pony. And why is that? Because when you check the DOM, when you check for a specific, do you have this image and do you have this text, and this is the exact text, you don't check everything else. You don't tell me, let me know what everything is on the screen and then find out. Checking the DOM for everything, traversing a big DOM, that would be a big graph, that would be very, very hard, and it changes all the time. But it usually doesn't affect, you do a lot of changes, but they don't affect how things look exactly. So taking the image and checking that you don't have something surprising would be a nice thing. So why ain't nobody using that? So it's not that simple doing, it's a bad idea to do just a simple bitmap comparison. And I'll show you only a few of those cases. I used to work at a company, a SaaS company that exactly did just that. And what I've noticed, look at that. I'm moving between two slides. Just you'll see those pixels right here. You see the difference? And it means this is the same browser running the same image, showing the same again the second time. It's using the rendering of the display adapter, which isn't. It says it's not deterministic. You can run it 7 times, and it's gonna look different. And for a computer, that's a big difference. The computer sees it, and it doesn't know. And here's another example. of things actually, it looks like it's moving, right? It's actually not moving, because what anti-aliasing does in 10 seconds, it means that if I want to have something like a circle or a diagonal line, what he's doing is the display adapter card, it's adding more pixels on the sides on its own. He decides, because he doesn't have enough pixels to create a perfect circle, so it's adding a different colors next to it, and of course it's every display adapter does it different way. So we get this, and we get this, and this is it even looks like it's moving, but it's not. It's just changing the pixels around it. So when we're talking about visual validation, you should probably. This is something that I want to make sure that everyone knows the difference between. There's a difference between automating and validation. That's a big difference, the stimuli and the validation. Because when you're talking about visual validations, visual automation, there's two types of things. There's object-based, which is Selenium and the commercial and the open source, and Sahi, which is a commercial tool. What they do, they look at the DOM. This is how you find an element, and you tell it to click it. The second option is image-based, which is Sikuli is an open source project from MIT, and Eggplant is a commercial tool. What they do is they find an element not just by the DOM. They're looking at the screen at the pixels, and they found something that's similar to some kind of element. For example, if you want to start a browser, it's going to look on the screen and looking for the icon of the browser that you have to put on the screen. And then it's going to double click it. You write double click on this image, and it's going to find it. It doesn't care if you're working on either operating system, if it has a DOM or not. If maybe it's images, it doesn't care. It's just looking for an images and clicks it. So the stimuli here, those kind of tools are based for clicking stuff. They're not used for validation. So I've seen a lot of people that use those tools to do just validations. They give, okay, let's use this, and instead of doing a click, let's tell him find this image, and let's just remove the click over. But he's doing, he doesn't, for validation, you probably need something accurate and not just 50% accurate. Visual validations, you have tons of open source tools and commercial tools that does that. They're all sprung in the last 2 years, so you can try them out. And the next thing I want to talk about, which I think is the critical part, in the first part of the presentation, I used this as telling you when it's ready. I used sleep for a few minutes. Okay, this is the source of all evil. Nobody should ever write sleep in his application. Never. That means you're putting a magic number, which works now. But if you run the same test on a VM, which is has very low CPU, or you're running several VMs on the same machine, that number won't cut it. So we want to remove that sleep from our applications. For our example, we did the login. We put the username and password that we clicked, and now we have to wait. We called the gallery and told it, tell me when you're ready. So the gallery now has to make sure it's ready, the page is ready, and work. So there's a few solutions. The first solution is something that you actually don't want to coordinate. You just, if we want to act on an element, let's wait until it's in the DOM. That's the very most simple thing that Selenium didn't have 2 years ago, but and it's nice that they added. It's called the explicit wait. It means wait until you have the element before you want to click it. So Selenium ended that, and what it means, the take the time, it means you just write a click, find an element, you click it, and if it's there, you click it. If not, you wait and wait and wait until it's visible, and only then you click it. It's called implicit wait in Selenium. You set up Selenium, say explicit wait 30 seconds, and when you find an element and you want to click on it, it waits for 30 seconds if it's there. So, and one of the most common options that people use is by the way, those are just my bad English, so you won't find those names out there. I've looked, but there's no convention for the names, the solutions. So the no smoke without fire, it means there's always a reason. Usually when you want to click on an element, and just say you're on LinkedIn and you click on load my connections. So and now it's gonna take the second option, which means that if I'm clicking on the load my connections, and then I'm want to double click on the first connection, if the connection list is empty and I'm clicking load my connections, and now I'm going to tell Selenium, find me the first element and then click it. He will wait until it's there and then only click it. But what if I have a list already and now I'm clicking, show me another connection of another friend of mine? It has to update there's already DOM elements over there. I want to wait. I know I want to test this, but I want it to wait till it removes that list and brings another one. So I want to wait. For example, I know that the first one on my list is someone called Abraham. So I'll wait for specific. This is the first option. I know that if I'll wait for something specific to be on the DOM, and Selenium has a wait for element. You give it some properties, for example, name equals Avi, and then you say wait till this condition is correct. And of course, we said the first list we didn't have Avi, but as the time passes and the HTTP request gets back and LinkedIn populates it with the new list, then we'll have the condition will be correct and it returns. Well, my personal favorite is the third, but there's the few companies that use this. So I want to show you something specific. What I want to show you is if you're on the login page and we want to return the new gallery, but before that, we want to make sure we want to wait for a specific event. This is the coordinator. I call it the coordinator because I have two processes. My test, which is one process, and the browser, the application that I'm testing, the application under test, which is running on its own. So I want to coordinate before I move on. So what I'm doing is I'm gonna call a method, which I'm going to show you. It's 4 lines of code, where I'm going to say wait till a signal. Then the application, who's running the people who's running the application should tell me send me an event that the gallery is ready, and they should probably emit this event only in testing. So we should probably, and I'll show you the code. And but first of all. So those guys, this is the application, this is our application, this is JavaScript, and they call the server, and of course when they get a callback when the server responds, and they do some manipulation, and now the guys who wrote the application, they just add this line, send test event, which sends a gallery ready event. So now I'm not doing anything, I'm not returning the page object, which is supposed to do all the gallery, making sure the gallery is there. I'm not doing it until one of the application is sending the events. So event in JavaScript, since it's not that It's not that hard to do, but actually we have something which is in Selenium, which is very, very basic in Selenium. In Selenium, as we said, we have open a browser, we have click on stuff or add some text, get text, and we said there's a wait for element. This is the 5 things that Selenium brings us. This is what every system brings us. So we should probably use one of those. And I'm going to use the last one, which is wait for elements. So what I'm actually going to do when we have, what is the send test event? So we added, we need this line of code. It means just don't add an event, just add an HTML element. Let's put it somewhere safe. And the testing will probably look for it. Let me show you how it's done. So if we split our application, usually the application, we put it in some elements. So we have the entire application here, and only in testing, we're going to have the elements of, instead of emitting events, we'll add HTML elements here. So finding those elements, if you have the idea of a test, this line of code, what it does, it means, okay, find that test and add there something to it. So what it means that if we send, and the previous line that we saw, emit gallery ready event, means it's adding just an HTML element with some class. And on the other side, sorry, because for the mix, because now we're looking at this is on the testing side, this is the implementation, 4 lines of code. It means they are asking me to wait for a test event called gallery. So what I have to do, I have to find, this is the CSS. I have to find an element with ID test, and inside of it, find an HTML, something with the same name called gallery. And we'll use Selenium, which has a wait for element, which is synchronously. We give it this selector, and it finds the elements. And when it finds the elements, we'll move on to the next statement. And so we're waiting so whoever called this, he's stuck on this on this line until that element appears. When that element appears, okay, we found it, that's it. We'll remove it because we want to keep it clear, and we'll move on. So as I said, I just want to show you. So we have this. We're calling the method wait for this, and we're waiting for the element. And then on the other hand, the application, when it reaches the stage when the gallery is loaded, it adds the element, making sure that we'll continue to this line, and now we can create the new gallery page. And that's it. And what I really wanted to find out, as I wasn't sure if anyone here most people do, who does here the front end? Who does here back end, mostly? So I wasn't sure if the terminology, if anyone knows, and we probably should explain what all those selectors means. In Selenium, actually in every, any one of those things like Selenium that helps you click stuff to move it, to do stuff on the browser, you always have an API which looks exactly like this. How do you find an element? How do I find? Well, when I wrote this kind of code, how do I know? I need to understand what it means. So I'm gonna explain just for a bit how does the selectors work. So I'm gonna explain a bit. So if we have a form which has those 3 fields, this is actually a graph, a tree, which one node is a form, and it has 3 children, with different attributes. So we'll take, for example, the first one, and basically you have a class. It has a class of an email. So finding an element, the Selenium API, okay, find me an element by a class. So that works great. When you're using CSS selector, it means, it actually means you have like an attribute. Every class, every XML has a tag name, an attribute which is comprised of a key and a value. So when you're writing that kind of CSS selector, it means class equals to email. It's going to find the same element, just one element, and this is it. And usually when a class, why do you use classes a lot? Because the classes are so common that you have a specific, for CSS selectors and also for the Selenium API. It's so common, so they added their own API. So actually we can find, so instead of using class, when you're using a CSS selector, you have, instead of writing attributes like this, when you say class equals to email, there's a shortcut. The shortcut is .email. That means class and email. So if I just look at this, this means find me an element with a class equals to email. And you can usually, if you combined two selectors and you put them together with no space, it means I want to have both. It's an AND. So I'm looking for an element which has an attribute, a tag name of an input, and I know it has a class name of an email. So this is a valid CSS selector as well, and this is a valid selector as well. We're using the space, which means within. So I'm looking for an element which has the class is equals to email, but resides is one of its parents, could be his parents, could be his grandfather, one of his ancestors, has a tag of a form. So why am I showing you all this? Because you need to find, when you find selectors, when you're using tests, you said, okay, let's find the email, the password, and click submit. On each one of those, we need to tell the browser we tell Selenium how to find that element. So we have to give it either one of those. Let's go over them. We have either an ID. ID is something that is exactly like when you have a class, but is a uniquely identifier. Usually you don't have, browsers don't enforce it, but usually don't have two elements with the same ID. That's right. And a class is something that it's a list of items that usually the designers use to do cross-cutting styling. You say, I want to find all the paragraph elements and have their font be some kind of font. So we'll be back for this in a second. We have the tag name, which you all know, divs and span, and now we have a few more in HTML5. We have, for example, we have a link. There's the link text. It means what the text is on. This is how our option is Selenium. So we can find it by partial. Just find me one of the links that has the text linked inside. So we probably won't use most of it. The API, if you're using login, then you probably have an ID for the login because you don't have two forms up there. So you can use an ID, but that's very rare. Usually when you have large-scale application, you have components. You have reusable components. So your component doesn't have, if you take the gallery, I can't have the next button. There's a previous button and show then the next image. I can't have IDs on it because I'm going to have in the same page two components, two galleries, or two YouTube instances. So I can't use IDs usually. Tag names are too generic. Everyone uses span and ID, so you'll have hundreds and thousands of the same span and div. So I won't use this. And sections, and the only thing that you have one of the cards is header and footer. And the link text you shouldn't usually be based on text because text changes. So when it changes, your application will break because you're looking for a a link that would say hello, and then and tomorrow we're going to change it to hola. So we want something to work all the time. So we need to use, usually you want to use either a class, but as we said, a class is, you have two things that are bad using classes. One is that if we have two galleries, so we can identify which one is going to return the both elements. We need to decide which one. And the second thing is, and that it changes that. The classes are used for how it looks. If we're changing the way our application looks, our test will start to break. If we have a class called password, and tomorrow we're going to change that because of visual styling, so our test will start breaking. So how do you do that? Is again using the page object. When we have a page object, if we have a page, and inside of it you have a component which is the login, you write a page object for each one of them. And the nice thing is that each component is responsive over very small units. He knows which locators are unique relative to that component. So for example, the gallery has, the developer who wrote the gallery, he added a class called next and a class called previous for those next and previous buttons. So we can find those for our specific gallery. So what if there are two instances? What we're going to do is when on the constructor of the gallery, we're going to find the gallery that we're using and pass it along. Either a specific locator which finds that element or a reference to that element. We're going to pass it along, and that gallery is he now knows inside that gallery, inside this domain, which is the gallery, I know exactly how to find everything that I'm looking for. For example, if in our login, we got a selector to find we know how to find the form, the login form. But then we said, okay, let's add a space, which means within that form, I want to find the user. No, this is I know how to find the username. So that's one way of doing it. And the second option, which is the best, is using Selenium 2 has a great feature which allows you to get a reference, although it's on different processes, get a reference to the specific element. So let me show you. If you have a driver, we open a driver. I can use Selenium to tell him to find an element. I'm giving him a CSS selector and find my element and get a reference to it. And the nice part is, if I give it to the gallery and say, okay, I found an element, now use this. This is the gallery. Now it can find inside of it, it can find the next, the previous, and all its components, inner components. He can use it to using the same element. He has a reference to that gallery page, and now he's looking just inside that component. So we have a web driver which actually simulates a browser. It has the API is navigate to and find an element and quit. That's basically it. And the find elements gets me an element, and inside of it I can looking for more elements inside. So if I wanna, one of my methods for the login, for example, is get the user field. What I'll probably be doing is, if I have a reference to the login element, I just look inside of it, and I'm going to look for for example, I get the locator for the user field, which is probably class user, for example. Let's say this will find inside the form. It will find. It will look for an element with class equals username. So that's basically it. And So guys, before I say thank you, I'm still here. If you have any questions, first of all, you can either ask now or later on when everyone's going. So yeah. Yeah.
Send in mocked objects so you know what state the data is in.
Yeah.
End-to-end, it's a big problem. Do you have any ideas or patterns around how we get the database into a known state before the tests run? Because I think you'll find people that do a lot of this type of stuff, the tests might work for the first week, then second or third week, they break.
Yeah.
It's all down to do with the database data not being in the right state. Do you have any patterns around getting the data into a state before you run the tests?
Yeah. So I'll repeat the question for the video. So the question is whether there's a specific thing that you can do there about when you're using about data, for example, databases, right? When you have a database and you want to have it prepared for this, when you mean your state, your application state, it usually means you're probably the UI state of your Angular app, I don't know, and probably the database, which has some value. So first of all, the most important thing is not always try from scratch. When I'm talking about scratch is create a new user. Since most applications, if you have a web application, so you usually have different users, and it's multi-tenant. Means that if I'm logging into Gmail, I can't see all the data that has that someone else sees. So if you're creating every test, you're creating a new user, you'll have a new set of, usually an empty one, which starts empty, and I know I can start from the same setup, which is an empty. But usually I want to start from some of the tests. I don't want to start from the empty state. I want to start from a state. For example, if I'm Gmail, I want to start with in a state that I have 100 emails. So I don't want to really send 100 emails. I want to start from a different state. So this is usually what you do is, since your application, there's two options. Usually what I see people is in their test, they're explicitly going to the backend's database and adding fields over there. Adding for that specific user, adding fields. And that's wrong, because everyone should teach, we said rule number one is every class or every model should deal with the things that it knows. And our test doesn't have to know anything about the database. So the best suggestion right now is creating a service. We have someone who knows how to write, adding a user. So the same in the database, we're adding a new service which it probably knows how to fake those 100 using those orb, using the object relational mapping. It knows how to add 100 emails. So we'll probably in the back end do another service which is just for testing. And in our testing, when we set up, we'll probably call it, send an HTTP request and say, can you add those 100 tests? And it's going to say, here, I'm done. And then we'll continue with the setup and move on. Any more questions? So we can take this offline. Guys, girls, thank you very, very much. Thank you. And it all started nice, but eventually it turned out things like this. And cadence, and I've worked at a lot of web development at startups like Weeks, and I have a startup of my own right now. And it all starts pretty nice, and it turns out like this. And we all start with, oh, that would be simple, and then it turns to something hellish, and then we'll said, okay, let's have testing so we can. We do want to refactor. So testing comes in handy, and that's what you probably know unit testing. So I want to straight up just what people mean when they talk about all those testing, the jargon. So we have a unit. Every unit has, you can test the unit, but then you can have several units, so you probably want to test all those, the bunch of those together, so that's integration test. And if you have everything together, so that's called end-to-end testing. But there's more than that, but when you write end-to-end testing, what do you test? Do you test just the functionality? So if you check that if I have a calculator and write 1 + 1, will it result 2? That's the functional testing. It does result what I wanted, but does it look exactly as I wanted it? Is it in the same place? Maybe it's hovering over the numbers, not in the correct location. Of course, I can check performance to see what if I run it once and it works? What if I run it 1,000 times and then it doesn't work? So maybe I have memory leaks. And the 100,000th time, it won't work. So, and of course, you can always run all the tests if you have a complex project. So sometimes you want to run just a specific test to make sure that there's no fire inside. That's called smoke testing. And adding everything together, the performance testing, the functional, everything together, that's called acceptance testing. And usually, until now, it required manual testing. That could be because you'll see in a second why. So Google, you search for cheese, and then you get a result, and you make sure you have, okay, let's make sure we have 10 results. And the first thing I did was last year, and it failed. I ran it, and it failed. So what? I just started it. This is the hello world, and it fails. So what's going on here? So we can see in short that it's it looks the same, but it's not. Usually, it's not the same language. If it's coming from front-end developers, and Selenium until now, the most developers wrote in Java. So you had to learn a new language. So you wrote your application in JavaScript and HTML, and now when you want to test it, you need to learn a new language. For most of them, that sucked. And in unit testing, we're very accustomed to having everything synchronized. We can do all the, of course, for the advanced feature, we do the mocking for some of the things that are asynchronous, but usually you call a method and then you assert that the state changed. And here it doesn't. That's why it failed, because when the browser actually wrote cheese, it takes time for the browser to send an HTTP request to the Google servers and get the answers back and display the result. So it's asynchronously done. And we'll see about the setup, because usually when you write a unit test, you just run it on the machine that you're running. For example, is anyone of you aware of who knows about continuous integration server like Jenkins or TeamCity? Yeah, so they get a list, they get your code, they get a list of tests, and they run it on the same server. But with here, you need a browser. So if you want to have a browser open, how do you parallel it to have like 100 threads? That's okay, running 100 threads on the same continuous integration system. But can you run on the same machine, let it open 100 browsers? No, it won't scale. Not more than 3, 5. Hi everyone, my name is Oren, and there's two things about me. I always have a bad hair day, and my English isn't that good. Well. So I'm not sure you can help with the first one, but if you don't understand anything of what I'm saying, either technical or just my English, so let me know. You can stop me, and I'd love questions, so you can stop me at any point of the talk. If I'll say I'll answer that in a few slides. So that's the worst thing that could happen. I don't have any candy to throw at you. Oh, actually I do. Ooh. So if someone answers, so I'm not sure if it should be like a bad thing or is it when it's a good thing if someone answers a correct question, so you get a trophy or something. I guess I should probably have what he had with the blue stuff. That's cool. Okay, so you should probably start. So just to find out how many of you are write code for a living. You yourself write code. Wow, so many developers. And how many of you have write, not just once, unit tests, right? Wow. And how many of you write end-to-end testing? So that's less. So we are going to be a little bit technical in the middle and the end of the session. So there will be a few lines of code, just a few lines. So please stop me if I'm going too fast or too slow. Just let me know. So we should let's go start. So regarding testing, we all know. I see that you all know the question, the answer already. So between theory and practice, well, in theory there's no difference between them, but in practice there is. So we always start. Every application starts beautifully. So and after a few weeks, it becomes like, so we all know it happens everywhere, usually in startups. I worked in companies like IBM, the WebSphere, group communication. So here's everything we wanted to just mention. And of course, we know the difference between white box and a black box. You said in all your unit testing. So unit testing is, you look at the gory details, but on the other hand, everybody's using it. You had more people here using unit testing than end-to-end. And the question is, of course, why? Why? Of course, we have different metrics for unit testing, or inside even a unit, we can either check, looking at it as a black box or white box. So black box means, I don't know, I don't care about what's the inside. I can check for, let's say, memory consumption or response time. And usually it's something like resembles user stories. You don't have very simple tests. It's not just 1 + 1 and then let's start a new test when 5 multiply 5 by 20. There are longer tests. Let's go log in and do something else. So white box, there's usually code involved. But the question is, that's not the reason everybody is doing unit testing. Unit testing looks harder, so why is everybody doing unit tests? Well, unit test, of course, in my opinion, it makes you write better code. That's one of the best reasons to write tests. You get, out of it, you get regression tests for your unit, which is great, it's a hard work, and of course, when something goes wrong, you know exactly what went wrong. So it still doesn't make sense. That if you go to Google and let's say Gmail and write an email and send it to ourselves and check that we received the email, we'll probably go over 40% code coverage in a 5-second test. So why do people prefer unit test over end-to-end? So why? The granularity, what I mean by this stupid graph is that to get 100% code coverage, which is the minimum of what people see as testing, as a good testing, you need to have a lot of unit tests, but you can have that in end-to-end in very, very few steps. So what's so wrong? Again, it's called the reverse ISCOM, which means that usually people base themselves currently on unit testing, a few integrations, very, very, very few acceptance tests, and manual testing. Usually that employs as well exploratory testing. You give someone, just browse the application for an hour and see if you find random bugs somehow. So we do want to find out what exactly is the difference between it. So for example, if we take the login, in unit testing, it seems very, very easy, okay? Have a new account, I'm starting, it's all the same. You have a setup, you have a stimuli, and then you have a validation. So you have a setup when you start a new account, then you do a login with a username as a password, and then what you usually do is you assert that you've moved from one state of the application to another, and the new state is correct, or it's at least part of it. So in end-to-end testing, let's throw away the intro and start looking what's so bad about end-to-end testing. We'll probably want to try open a browser. That will be set up. And then we'll set up the username, we'll set the password, and we'll click the login, and then we'll validate that we're logged in. So I'm going to talk about mention Selenium code in this talk, but everyone's have the same level of abstraction. Selenium is they all navigate, let you steer the browser. So they all give you exactly the same thing, which is usually navigate to a URL, some URL, find some element, an HTML element, and let's add some text to it. And then that's the stimuli, the setup, the stimuli, and then we'll have, for example, this is Google. This is real Google code. They have this example at the Selenium code. They improved it just a bit lately, but you go to the Google, you go to